Hi there. My name is John, and I'm going to be giving an overview of my E98 final project, the adjustable power supply. So without further ado, I'll start off with talking about the transient simulation conducted in LT Spice. Here's LT Spice. I'm going to go ahead and open up the schematic that I made. So first of all, you can see the circuit that I built, and basically what we have here is a switch box simulated by these voltage controlled switches. This is connected to the LT317 chip, which is an integrated circuit used for regulating power and current. This is configured as an adjustable power supply that can change the output voltage based on a formula for resistance. So the resistor divider right here sets the output voltage based on the equation given in the data sheet for the LT317. So when you run the simulation here, you can probe the voltage at the output and see as each switch gets turned off, the output here is decreasing. If we load up a trace, we can see that essentially where we put this, a window pops up here, and we can probe around on the voltage and see that each time it is dropping 1.5 volts. So here's 5 volts, 627, 7.5. So around here, you can see the jump from 1.25 volts. So moving into the circuit design, we studied the fundamentals of the LM317 or LT317 in order to solve the math and set the resistance. I use a potentiometer because it's a lot more adjustable than a simple resistor table, fixed resistor value. So we studied how varying the resistance here of this R2 value can basically adjust the output according to the equation shown here for V out. So based on that, went ahead and built a physical circuit board. The LT317 was used here, along with a tunable resistor, variable resistor. Basically, this setup is really simple. We have a terminal block here for the plus and minus grounds, or plus or minus rails, and a capacitor here to smooth the output voltage. The adjustment fixed resistor here is used for stability. 240 is a common value. And yeah, so here on the back of the board, you can see a really simple breadboard type layout on this PCB, this prototyping PCB. The total cost was $13 for all the components used, and it resulted in a basically successful test to plot the different voltage values simulated by the LT Spice design. So you can see here in our results that min and max voltage recorded from the devices were very similar, and we could conclude from that, based on error analysis, that the LM317 was working as designed and within the tolerance of the device. So thank you for listening to my video, and I will now demonstrate the circuit actually working. So here we have the board. Here we have the buck boost regulator providing power to the board, and then we have a readout for the output voltage. So right now we're at the minimum value, 1.25, around that, and you can see it very smoothly increments with the resistor, variable resistor, up through the range. So you can use this little power supply to test electronics or anything that you'd like in very fine increments. So yeah, I hope you enjoyed learning about my project, and hope you can see how this technology is a very good application way to learn electronics. Thank you.